Okay, let's begin. Hello everyone, and today I'm going to about my project, and my project is about the food. It's related to the leaves segmentation, and it have like deep learning and no deep learning method. And why I choose this topic, and that's a good question because you guys, like the food is super important for our like daily life, right? And some like a country they are like poor and they are some people are super hungry, and that's why we need to like have like food more production. And like for the daily life, the like farmers, what they are did is like they have to like watch the like leaf and see if there's some like a disaster or not. And it's just like a repeated work. And for example, if there's like some software could monitor this one by themselves, and it is the farmer could get the alert automatically so that they don't have to check it every day, right? That's why I was this idea. And just I mentioned this one using like a deep learning, and also like no deep learning also is used for like compare with the both method to see which one is much more better. And for the data set, if you guys see, and the like leaf disaster segmentation, the data set is get from the cargo. And it's pretty new project. It's almost no one is coding it. And for the cargo is like chain is like 2500 leaf image, and also there's a mask, and the validation kit data is like 400 40 leaf image, and also the mask. And here's the link if you guys interested could download it. And previous approach, and actually in the like leaf segmentation there's some research papers there. I was found they also using deep learning, but what they did is like they could using like a unet, and they only compared with unet, and to see it's good or not. But in here, I was did more thing for them. For example, I compared different architect for the model. It's not only using the UNet, and also have the UNet plus plus and the DeepLab v3. And also, I was changing the encode. And for example, like the encode could using like ResNet, and also like VGG. And here like I list a lot of like encode to see which encode is the best for different model. And yeah, just I mentioned here, like using the deep learning is pretty similar as the transfer learning. And here, like I changed the encode and have the and training the like decode part so that it could help the performer. And also like no deep learning is using some like random forest. It just training it. And if you guys see the like architecture here, the UNet and the UNet plus plus, and here UNet is like if you guys see here, it's like UNet is pretty like U here. The half part is like encoder, the another half part is decoder, and the UNet plus plus is like the idea is come from the ResNet. It's just like how more fully connect layout, and it just like connect some like encoder with the decoder part, add more layout. And here like if you guys see it, and the Unit plus plus could like improve much more accuracy, and we can see it. And for the deep lab v3 is also another super popular. Current is just add more like CNN to it to have a better result for it. Yeah. And here like encoder I using like EfficientNet B7, EfficientNet P0, ResNet 34, ResNet 101, VGG 16, VGG 19, and let's see. And the code was like training in the Duke DCC on demand with GPU, and it's pretty fast. and also it was deployed in the Google Cloud platform with Kubernetes. It also has GPU. I also want to improve the efficiency for it. And also the matrix here is like using the IOU, and the why I choose the IOU, not the accuracy or something else, or precision or recall. The reason why is like IOU in here for the certain the problem is like image segmentation is much more efficiency, it's more accurate. For example, LU is the formula we can see here is like a area or the like overlap over the area or the unit or the unique, and this one is like could much more increasing the accuracy, so that we can better get the better result for it. And here's the result for the all model here, like for example, we can take care of the first half, like for example in the here deep learning lab v3 RASnet 34 and vnet RASnet 34 and unet plus plus RASnet 34, and we can see here like a unet plus plus in the RASnet 34 is unet plus plus is a much better performer one. And if we guys see for example unet plus plus 34 this one, and with unet plus plus 101, and also unet plus plus efficient b0, and we can see unet plus plus 101 is pretty similar as a unet it's pretty similar to this one, unet plus plus efficient b7, and overall we can see the performance best one is this two, is unet plus plus 101 and unet plus plus b7, and if you guys are interested, you can just see the graph here and compare the different model with different encoder to see which one is better. Yeah, and the accuracy here is pretty high. If you guys see accuracy in here is not good enough to compare the performance of the model, and IOU is 0.7879, and accuracy 0.97, and precision 0.92, and recall 0.89, and f1 0.191, and IOU here 0.93, and dice is also another popular one. It's pretty similar as IOU. It's also 0.191 here. Here the matrix is for the IOU and the dice, and this one is I coded it by myself, and because I didn't find any open source library, and for the accuracy precision require f1 is pretty easy to find the open source library to calculate. And for the no deep learning method here, using random forest, you can see the IOU here 0.9 0.77 is over 10 image size is it's not good honestly. And but there's another problem. If we guys see it's one training it's using no deep learning, it only using the CPU, and it heavily depends on the CPU. If the image size grows by, it will just frozen the CPU, even I using the DCC on demand platform. And because it didn't using the GPU, that's why it's a big problem if the image size is large. That's why I choose 10 image to train it to see how the performance, but it's still so bad honestly. And the future, this project is pretty useful, and it could be using in other areas, for example in medical image analyzing for the cancer prediction, and you can just change the image, the data, and the same model here, you can you can train it using the different medical image data, and using the same model here, and you can train it, and then the same code here you can use in other area is pretty useful, and I could show the demo here. Yeah, and if we guys see it, the diamond here. Okay, I open my website here. Yeah, here's the web, and I just choose some the bad one. Yeah, and it will get the email automatically once it have some bad performance. For example, I just randomly choose one image. And see here is a yellow product which is larger than the threshold, and I was supposed, yeah, see it will get the email automatically, and if we guys see, and just wait it, yeah, just wait it, yeah, see here, I just get the email, and see it's 0.6 is larger than the threshold. It could get an alert automatically. That's why it's pretty useful in the software, and it could monitor the leaf, and not only it could upload it, because the farmers you could using some camera, and here like I just found some because the reason I just here is I could let you guys is here the different model to see how to perform here, and I just see this one is it's also good. I mean, but this one is much more good, but this one using like a more large size, so it's try. I mean, here like I using the camera one, so I choose the bad one first. Yeah, and then I could just using the yeah, yeah, see here. Okay, it's working. Yeah, yeah, thank you. That's the demo. And yeah, and okay, I could introduce like a deployment part. And for example, like if this project is using the Google Cloud and using Kubernetes, and also with the GPU, and here if it's had just like recently I just opened my like demo, it's just using the GPU here, so that it makes it much more faster, and also like the repo is here, and then if you guys interesting, could just open my like repo. Here's like the workflow is CI/CD, and it's using Docker, and automatically push to the Docker, and also like the Kubernetes deployment, and also the data here like this form, and also there are some pre-trained model. You guys, if you guys interested, I could download it, and it using the like the Duke DCC on demand GPU to training it, and here's the result, and thank you so much. And it also have like a no deep learning model include. It's just like the it's not so good here, so no deep learning. And thank you so much. Any question?